Hello friends, I am Dr. Sarika Panwar. I welcome you all for data preprocessing in data analytics part 3, and today we will discuss about the normality. What is the role of normality? Initially we need to understand what is the role of normality in data preprocessing. By using the normality we can find out the missing values. Normality is defined as distribution of data for a particular variable, and we before pre-processing of the data we actually assume that data is normally distributed, but if it is not, then we need to normally distribute it so that we can get the proper result for the data analysis. Then normality is assessed by using the different ways, like we can find the skewness and kurtosis. Skewness means that the responses did not fall into normal distribution but were heavily weighted towards one end of the scale. In this diagram we can see that if there is no skew in the data, then it will be this proper curve. There will not be any skew in the data point. If the data is left skewed, then the skewness value will be greater than 1, and this is how the graph will look like for left skewed graph, and this is right skewed graph in which the skewness value will be less than -1. That will be plus 1 for the right skewed, and it is -1 for the left skewed, and if it is in between, then it is fine. Okay, so if normally distributed data will look like this, there will not be any skew in the normally distributed data. Normality can also be accessed by using the kurtosis. Kurtosis is a measure of whether the data are heavily tailed or light tailed relative to the normal distribution. Now see, this is the normal distribution. This green curve shows the normal distribution, which is also called as a mesokurtic graph. Data sets with high kurtosis tend to have heavy tails or outliers. This is a heavily tailed data set, and this graph, this light green color graph, it is the data sets with low kurtosis, which tends to have the light tails or lack of outlier will also be there. Linearity is also used to find the missing values. Linearity refers to the consistent slope of change that represent the relationship between the independent variable and dependent variable. If the relationship between independent variable and dependent variable is radically inconsistent, then it poses certain problem. There are several tests available to check the data linearity in software like ANOVA test in SPSS software. We can statistically adjust the data by using several methods. Weighing. In weighing, each case or respondent in the database is assigned a weight to reflect its importance relative to other cases or respondent. Weighing is the most widely used to make the sample data more representative of a target population on specific characteristics. Yet another use of weighing is to adjust the sample so that greater importance is attached to respondent with certain characteristics. Variable risk specification is also a method. One of the method. Variable risk specification involves the transformation of data to create new variables or modify existing variables. For example, researchers may create new variables that are composites of several other variables. Dummy variables are also used for specifying categorical variables. Here in this diagram, in this table we can observe that how the dummy variables are created for statistically adjusting the data. Now this is the class of product users. Non-users are there to whom original variable code 1 is assigned, light users are assigned 2, medium users are assigned 2, 3, and heavy users of a product are assigned 4 code. But now this original variable code is now replaced with the dummy variable code, where x1, x2 and x3 are the 3 dummy variables. For 1 it is x1 is assigned 1 and x2 and x3 are assigned zeros. Like that in original variable code column 2, it is replaced with x2 is equal to 1 and x1 and x3 is equal to 0. So if we get x3 all x1, x2, x3 is equal to 0, means that particular user will be a heavy user. So x1, x2 and x3 dummy variables can be used to represent user or non-user group. Then box plot. We have seen the box plot for finding the outlier in a data point. Box plot actually is a method of displaying the distribution of data based on minimum value, first quartile, median, third quartile and maximum. It can show the outlier and what their values are. In this box plot, we have already seen that box plot. This is the minimum value in the box plot, this is maximum value, and minimum and maximum values are calculated with reference to Q1 and Q3. And median is actually the second quartile, Q1 is the first quartile and Q3 is the third quartile, which is also called as 75th percentile. Thank you, student.